Okay, yesterday we were learning about parallel lines and what you get if you have parallel lines. We found out that the corresponding angles would be congruent. Now, let me just show you real quick. Once again, if we had parallel lines cut by a transversal, then one of the things that we can get is corresponding angles are congruent. They're in the same position, right? Remember? Take one angle from this group, one angle from this group. We also learned that the alternate interior angles are congruent, right? And you'll remember that anytime you have the alternate interior angles, there's like always this zigzag pattern. Every time you see this, that's always what I use to help me recognize it. There would be a zigzag pattern. So that was the second consequence. The third consequence we had was that the alternating exterior angles are congruent. Remember? You need to flip sides, okay? Because there's the transversal. Alternating means you flip sides, and it's got to be on the exterior part, right? The exterior part out here. Remember, this portion in here is called the interior. And so then we have the final set. These two angles on the inside, on the same side of a transversal, are supplementary. So they add up to be 180 degrees. That's if we have parallel lines. Those are the four consequences. Okay, so now today's lesson is very similar to this, but it's in reverse. Basically what we're going to have is we start out, well, and we say, look, if you have some corresponding angles and they're congruent, then the lines are parallel. Or if you have some alternating exterior angles congruent, then those lines are parallel. Or if you have some alternating exterior angles congruent, then the lines are parallel. And if you have a couple angles in here that are on the same side of a transversal and they add up to be 180, then you have the lines are parallel. And that's all this lesson is. I mean, basically, in some sense, we're done already. But we'll go through it a little more slowly and do some problems along the way. So let's get started. Lesson 3.3, prove lines are parallel. So our objective, students will be able to prove lines are parallel. So this is one of the four ways that we could prove lines are parallel, but you can also show that lines are parallel by showing that they have the same slope. I mean, if this slope here is, you go over 4 and up 2, and this line you go over 4 and up 2, they have the same slope, and that would mean that these lines are parallel. Okay. But in this section, we're going to learn the four ways that I mentioned earlier by looking at the corresponding angles, alternate interior angles, alternate exterior angles. And we're also going to be looking at the same side. So keep in mind that there will be other ways to prove that lines are parallel, and that will actually come later on in the chapter. So let's start out by practicing by writing the converse of the statement. Remember, the original statement is the conditional statement. It has an if part and a then part, and this part here is the P, this part is the Q. Remember, that's how we write the conditional statement. If P, then Q. To write the converse, we have to switch the P and the Q. So then we'd write if Q, then P. Now, sometimes to do this, you have to play around with the words a little bit, and sometimes you have to even add in a few extra words just to make sense of it. So this would be the converse. With that thought in mind, can you go ahead and write it yourself? This would be a good practice. Take a moment. Maybe a student can do it for us on the Mobi pad here for us in just a few moments. Let's see. This part needs to be first, so I need to say if Josh needs an umbrella, then it's raining. There you have it. What we did is we put this part here, this part here, and we put this part over here. And that's how you create the converse. Now, by the way, you'll notice that a lot of times the converse is not necessarily true. I mean, it makes sense this direction. If it is raining, then Josh needs an umbrella. But Josh needs an umbrella, it might be because it's a really hot day and you're using the umbrella as shade. Or maybe it's snowing outside and you want an umbrella to keep the snow out of your face or something like that. So it's not necessarily true. So that's one of the things we learned in chapter 2. The converses might not be true. In this section, it turns out the converse will be true. So let's take a look at them. So, if two lines are cut by a transversal such that the corresponding angles are congruent, or the alternate exterior angle, alternate interior, blah blah blah, consecutive angles are supplementary, then the lines are parallel. Now, these four statements are the converses of the statements that we learned yesterday. So it turns out these are going to be true. In fact, they turn out to be theorems. So let's take a look at them. The formal names. Notice the first one is a postulate. That means we won't have to prove this one. And the one that we don't have to prove is the corresponding angles converse. Now, by the way, notice there's the word converse on all these. If you leave that word off of there, then I'm going to think that you're referring to the previous lesson, which was lesson 3.2. And in that lesson, we had parallel lines to start out with, you see. But in this section, we don't start out with parallel lines. We start off with corresponding angles. And then our conclusion is that we have parallel lines. So make sure you have the word converse in here every single time you refer to these theorems. And that will remind us that we've switched the two around, the P and the Q. Okay. So in any event, this one's a postulate, these three are theorems. So we could prove these, and often to prove these we use that one, the postulate up here. Well, let's get started on some more problems. Maybe take a look. Is there enough information? Well, if we're going to show that the lines are parallel, we want to use one of those four cases that we had mentioned earlier. One of the things we can try for is the corresponding angles. And we can check, are they congruent? Well, if the corresponding angles were congruent, then I'd have to show that this angle here is congruent to this angle here. You see? And I know that one's 75, but I don't know if that one's 75. Oh, but here, take a look here. Notice that these two angles here form a linear pair. They're a linear pair. And I know, because Mr. Russell taught me this back in chapter 2, that linear pairs are supplementary. And that means they have to add up to be 180 degrees. Well, that means this angle up here has to add up to 180 with this one. And I think I could do this in my head. That's 105. So that means that this would be 75 degrees. Okay? And now that I have that that's 75 degrees, I now know then that this angle is indeed congruent to this angle here, because we have the linear pair to determine that that was 75 degrees. So we're going to say yes, because we have a linear pair and we determined that the corresponding angles were congruent. Okay, so that's the explanation part. Anytime you see this on your assignment, you need to do something like this. You have to write out a sentence. You have to justify your answer. Make sure you don't leave that part blank, because otherwise you're going to lose about half credit. Well, in any event, this was only one of the ways that we could have done it. I mean, there was like 3 other ways, and so I'll just briefly mention those. We could have shown that the alternate interior angles are congruent. We could have used the alternate exterior angles. We could have shown that they were congruent. We could have shown that these were congruent. We could have shown that these were congruent. Or we could have showed that the consecutive angles were supplementary, basically equal to 180 degrees, which is kind of what you could do here. I mean, you could have done this, you could have done all 4 of these if you were clever, but we chose this one, the corresponding angles one. So, and that works. So keep in mind that we did use the linear pair idea again. Interesting. Okay, so I'm sure when you're studying biology, you're going to want to figure this out, whether the scales are parallel or not. So notice what a biologist did. They're taking a close-up of this picture here, and they just kind of imagined this going further, did that, and then they measured that angle there, okay, and they measured this angle over here. Notice the zigzag pattern, and they found out that those 2 angles are congruent. Well, those 2 angles are congruent, then what happens? That can only happen if those lines are parallel. So there you have it. How can you tell whether the sides of the patterns are parallel? Well, we can tell because we measured the alternate interior angles right here and found out that they are congruent. So indeed, these sides are parallel. I've always wanted to know that. How about that? Well, here's a proof, and what we want to do is prove that if 2 lines are cut by a transversal, the alternate interior angles are congruent. Then the lines are parallel. Okay, so that's our job. We're trying to prove that lines are parallel. So one of the things I want to remind you about is this little note over here. Before you write a proof, identify the given and the proved statements for the given situation. Okay, or draw any diagram. Okay, well, excuse me, I read that wrong. Or for any diagram you draw. Okay, so there's the proved line, there's the given line. So let's take a look at what we need to do. It's going to disappear. So This time what we need to do is, somebody came along and gave you the reasons. What we need to do now is come up with a statement. Oh, excuse me. We have some statements and we need to come up with the reasons now. Okay, so this proof is like half done for us already. Well, notice the first one's easy because that's exactly what was given, right? Okay, so we can say that the reason for this is that it was given to us, and we just simply write given. Okay, so angles 4 and 5 are given to us. They are congruent. Okay, so now we want to say that angles 1 and 4 are congruent. Well, remember, there's two lines that crisscross right here. There's two lines that crisscross. Okay, and when two lines crisscross, you're always going to get vertical angles in there. And so angles 1 and 4 are vertical angles. And we learned back in chapter 2 that vertical angles are congruent. So this is simply called the vertical angles are congruent. And that was actually a theorem, so we'll just abbreviate that as a theorem. Vertical angles are congruent theorem. Okay, well, so now what can we say? This setup here, this reminds me of a setup that we've seen. Notice that this is being used twice. Remember that setup we had a long time ago? Well, we've had it multiple times. We had if A equals B, B equals C, then what can we say? A is equal to C. That is the setup we have. There's the thing that's being repeated. And so this part here would be your B. This part here would be your B. And that means that's your A and your C right here. So what we could say is that angles 1 and 5 are congruent. Well, that setup is common. We've seen it lots of times now. Hopefully you remember it now. It's called the transitive property. And what type of angles are angles 1 and 5? We just showed that 1 and 5 are congruent. This angle 1 is on the top left, and this bottom group here, angle 5, is on the top left. So those are corresponding. Well, we just had a postulate that said corresponding angles are congruent. Converse. Okay, so this is the corresponding angles are congruent. Now remember, there's a word that we have to have with this in order to have it right here. It's called the converse. Remember, the converse, these converses, they are the ones that give you the parallel lines. So if you have a parallel lines and you're trying to prove lines are parallel, like we did just now, then you're going to definitely want to have this word converse included in your description here. We just showed that the corresponding angles are congruent. Since we did that, we can now honestly say, oh, those lines are parallel. So there you have it. We just did a proof. Well, we did half of it anyways. Now here's a transitivity property for parallel lines. It's pretty straightforward. It basically says that P is parallel to Q and Q is parallel to R and P is parallel to R. I don't think there needs any explanation. That's pretty straightforward and it's pretty obvious, like duh. So let's just write it out what it's saying here. It says that this line is parallel to this one, and then we know that this one is parallel to this one, then this one is originally parallel to that one. Like whoop-de-doo. Okay. So in the figure, each rung of a ladder is parallel to the rung directly above it. Okay, so what we know then is that this one is parallel to that one, but each rung is parallel to the one above it, right? So this one's parallel to that one, and that one's parallel to that one, and this one's parallel to that one, this one's parallel to that one. So what can we say about the top rung? Well, we can say the top rung is parallel to this one also by the transitivity property that we just looked at on the previous slide. It's parallel. Okay, by transitivity. Okay, by transitivity. And this is a transitivity property for parallel lines, that's all. Okay, so there you have it. We've kind of looked at the couple different types of problems. You can now work on your study guide, and hopefully this won't present too big of a challenge as long as you can do some algebra problems. So how do you prove lines are parallel? You can prove lines are parallel by showing corresponding angles, alternate interior angles, or alternate exterior angles are congruent, or by showing that the consecutive interior angles are supplementary. The one that most people struggle with is this one. Remember, in that case there, you have to show, let's just redraw it here, you have to show that couple angles, like angle 1 and angle 2, you have to show that they add up to 180 degrees. So angle 1 plus angle 2 must equal 180. So I'm just telling you from experience, this is the one that people screw up on. And it's natural because they're used to setting everything equal to each other, because this set is congruent, those are congruent, those are congruent. So you automatically want to start setting up an equation. Well, this one over here is equal to this one over here. Okay, well that happens lots of times in those three cases, but not this one. So your equation for this one is going to look something like that instead. So cuidado, look out for that. Be careful. And that's the end of this lesson. So